Alright guys, welcome back. This week we are going to continue talking about nuclear chemistry, and we're going to dive into radioactive decay. We're going to be first talking about the three main types of radioactive decay, and then later this week we're going to jump into how to signify them using equations. So right now, this picture, I don't expect it to make sense right now, but it actually is a great way to signify what radioactive decay is. So let's jump right in and talk about the first type of radioactive decay. So basically in radioactive decay, something about that nucleus is unstable. And if you guys remember, nuclear reactions are different than chemical reactions in that they involve the nucleus or that core of the atom as opposed to the electrons. So the first one we're going to talk about is alpha decay. So a little context, this occurs because that nucleus is unstable because there's too many protons. And I give you guys a little key here. There's too many protons in this nucleus. So this particular element is going to undergo alpha decay. So what the nucleus is going to do is it's going to emit an alpha particle. And I'm going to signify this here. It's going to emit an alpha particle. And if you guys can see, an alpha particle is going to consist of 2 protons and 2 neutrons. But what else consists of 2 protons, 2 neutrons? Oh, helium, my friend from the periodic table. So an alpha particle is actually just a helium atom or a helium nucleus. So I'm actually going to write that here, that I can signify an alpha particle as a helium nucleus. And again, I'm going to put the mass up here and the proton number down here. 2 protons, 4 total subatomic particles in that nucleus. So in alpha decay, too many protons. I'm going to emit that alpha particle, and I'm going to emit energy, and I'm going to have a new product. And where are my pens? So if I got rid of 2 protons and I previously had 6, I'm going to have 1, 2, 3, 4. And again, remember I got rid of 2 neutrons as well. So this time I only have 4 left. And if I double check my periodic table, I see that I made an entirely new element because my proton number changed. So I went from having 6, so I was carbon. Now I only have 4. I am now beryllium. So in alpha decay, I'm actually going to turn into a new element. I'm also going to have a product of that alpha particle. I'm also going to release a ton of energy. So let's talk about the dangers of this particular type of decay. You've all seen those symbols, those radioactivity symbols. Well, thankfully, alpha decay is actually not the worst type of decay. It's actually the least dangerous of the 3 we're going to talk about today. But it is still dangerous. But the reason it's the least dangerous is because the alpha particles are relatively heavy. So they can't really travel through air all that far. I think they can only go about a few centimeters. They don't really penetrate. They can pass through, let's say, like a sheet of paper or a very, very thin layer of clothing. Otherwise, they can't really get through. They can burn your skin, but they can't really penetrate to the tissue underneath your skin. However, if alpha particles do get into your body, and this happens a lot with smokers, they can cause significant damage inside your body. So people who actually inhale smoke, they tend to get this radioactive element of polonium-210, which starts undergoing alpha decay in your lungs, and too much exposure to this type of decay actually causes cancer. So it's dangerous, the least dangerous, but still you kind of want to steer clear of this guy. And that's pretty much all I really want you to know about alpha decay. So let's take a moment to summarize. This occurs because the nucleus is unstable. So let's write that here. Occurs due to unstable nucleus. And it does form a new element. I'm sorry I'm taking like shorthand notes. I'm trying to keep this video semi like short. So alpha particles, what are they? We discussed it a little bit ago. They are 2 protons, 2 neutrons, 2p, 2n, same as a helium nucleus. And I'm going to write that like that again. And let's just take a quick note that this is the least dangerous of the 3 decays we're going to talk about. So alpha decay, I have too many protons. This is what I'm going to undergo. Let's talk about the next type of decay. We have another type of decay. It is called beta decay, and this also occurs because we have that unstable nucleus, but instead of emitting a alpha particle, now we emit a beta particle as well as energy. So let me just write plus energy here, just like I did last time. So we emit a beta particle as well as energy. So if you look at my key here, I put proton, neutron again, but this time I put electron or a positron. So a beta particle is either an electron or a positron. And you know, an electron is a negatively charged particle. A positron is just a positively charged particle, or sometimes they call it an anti-electron. So when a beta particle is an electron, the decay is called just beta decay, sometimes beta positive or beta negative decay. I'm sorry. But I'm just going to call this beta decay. And that is when I have a neutron and it decides I shouldn't be a neutron anymore. I'm going to turn into a proton and an electron. So I do change my element. So that neutron becomes a proton, meaning it's going to go up 1 on the periodic table and turn into an entirely new element. Sometimes it undergoes what we call beta plus or beta positive, and that's going to be here, beta positive decay. So there's 2 types of beta decay. There's just the one where a neutron decides, nope, just kidding, I want to be a proton. There's also the kind where a proton says, you know what, I really would rather be a neutron, and changes into a neutron and then what we call a positron. Let me write that here. So this one's going to signify a positron, and in beta, normal beta decay, we're going to have an electron. Both cases, I either become a proton or I lose a proton. So I do change into a new element. So in beta decay, neutron becomes a proton. The mass number never changes. Or the proton becomes a neutron. They just kind of switch. So the mass isn't going to change, but the proton number and the elements will. So that's beta decay. Let's talk a little bit about the dangers of it. This is, let's say, the medium danger one. So it's a little more dangerous than alpha decay because it can travel a lot further through air. It can pass through that sheet of paper as well as like a thicker layer of cloth, but it can't really get through metals like aluminum or a few centimeters of wood. It can penetrate the skin and do damage to the tissues. They're terribly, terribly harmful if they are ingested or inhaled. So steer clear of this beta decay because it is much more dangerous than alpha decay is. However, it's not the most harmful type of decay. You still want to just stay away from all decays, guys. So I don't want to make it sound like they're not bad. They're all terrible. Just this is the medium-sized terrible one. So let's summarize. Beta decay occurs again because of that unstable nucleus. There's either too many, and in alpha decay we had too many protons. So we could have too many protons or neutrons. So if we have too many protons, we're going to turn into a neutron. If we have too many neutrons, we're going to turn into a proton. It's kind of give and take. It's either one. In both cases, a new element forms. So just like before, we emitted an alpha particle. This time we emit a beta particle. So I'm going to write emits beta particle, which is just either a proton plus an electron, or it's going to be that neutron plus a positron. Basically, let's write that this is the medium decay, and I'll just write danger because I probably should have said mildly dangerous compared to the other two. So it's about the medium of the dangerous decays. Very dangerous, all of them, but that one's going to be right in the middle. All right, last type of decay, and then I'll give you guys like a little quiz on this stuff. Not a quiz, just an assignment. We're going to talk about gamma decay, and I tried to draw what happens in gamma decay. Don't criticize me for my artistic ability. So let's start by talking about what is a gamma ray. It's just an electromagnetic wave, and they're just waves of electric and magnetic energy that travels through space, you know, at the speed of light, which is super fast. And the energy travels in like packets. Like, I'm going to put quote unquote packets because I don't really know what word to call it. But these packets of energy are called photons, and photons of gamma energy are called just gamma particles. Alpha and beta occur when like the nucleus has too many protons or an unstable ratio of protons and neutrons. When the nucleus emits a particle, it actually gains or loses 2 protons, so the atom becomes a different element. Gamma decay is different than that, in that it occurs in a nucleus that is just in an excited state, and it just has too much energy and it doesn't know what to do with itself, just like my dog all the time. So this happens after alpha or beta decay already occurred. Because the only energy is emitted from gamma decay, the number of protons remains the same. Therefore, the atom actually stays the same. It's just a super excited atom, and it's just gonna want to get rid of a ton of energy that it has. So my dog, she can go for a walk. I'll walk her 4 miles, and she'll still come home with a ton of energy. She's not going to turn into a new dog, but she's going to still want to run outside and just get rid of some of that excess energy. And in this case, you can see, same thing. It's the same element. I just kind of crushed it together on this side. It just kind of emits energy on this side. Nothing changes about the actual atom. So just like we talked about before, let's talk about the dangers of gamma radiation. They are the absolute most dangerous. They can travel so much further than alpha and beta. And they can penetrate materials like way more deeply than the charged particles from alpha or beta. So gamma rays can be stopped only by like a thick layer of lead, or meters and meters of concrete. So they can definitely penetrate and damage cells inside of our bodies and cause more damage than I would like to talk about. So let's summarize. Gamma decay, they carry photons of energy. So they carry photons of energy, and they are the most energetic. I'm going to underline that a couple of times. Energetic. I think I spelled that right. So the nucleus emits that package of energy. So emits a gamma particle, which I called before that quote-unquote packet of energy. So just think of gamma particles like Paisley. Just crazy, just always energized. So there's no elemental change in this one. And let's just put that it's the most dangerous form of radiation. All right, so I tried to keep it below 15 minutes. Looks like I did, but to summarize, we talked about the 3 different types of radioactive decay. We have alpha decay when we have too many protons. We have beta decay when we have either too many protons or neutrons. And then we have gamma decay when we are just super excited and we just need to get rid of some of that excess energy. Alpha, beta, gamma in order of danger, least dangerous to most dangerous. And feel free to play back the video for some of my explanations. I do realize that I talked a lot more in this video and did a lot less writing. So play it back, ask questions. Other than that, you have a quick worksheet to do on Google Classroom. And then tomorrow we're going to jump into representing these guys with equations. Good luck, guys.